want to talk about a group of compounds called nitazenes. On the street, and what patients tell me, it's called the Frankenstein drug, or iso, or meto, or proto, or ito. So what's going on with these compounds? These compounds, once again, they're very old. In the 1950s, a company, Seba Gale, developed these compounds as an alternate to standard opiates like oxycodone, hydrocodone. And what they wanted to do was find something that was less addictive, but what they created was something that was so potent it was too risky an overdose. I'll get to the reason these compounds are so dangerous and why they are so prevalent in overdoses. Now, everyone knows what fentanyl is and carfentanil, the very potent opiates. Fentanyl is one of the most potent opiates, and then carfentanil is 100 times more potent than that. These drugs are not in that category. They are anywhere between 500 and 4,300 times more potent than morphine, which is way less than carfentanil and fentanyl. But why are they so dangerous? The four that I want to talk about is isonitazene, metonitazene, protonitazene, and itonitazene. Here's the interesting thing about these drugs. They only last 40 to 60 minutes, even less in some people. And they're not as potent as fentanyl or carfentanil, but why are they so dangerous? Well, there's two qualities to the receptor that they're hitting, the mu-opioid receptor. That's the one that gets you high, that decreases pain, that causes sedation, makes your pupils real small, causes constipation, gets you high, promotes addiction. Or something called the KD value. Now, why even bring that up? The higher that value, the more binding affinity the molecule has of the receptor. So let's say this is the receptor, and this is the opiate. Normal opiates, they latch on, not too tight, but they stimulate a lot. You remember buprenorphine came along. It latched on really hard. And what it did was it kicked off all the opiates, hydrocodone, oxycodone, morphine, meperidine, codeine, heroin, and put people into withdrawal. Buprenorphine was the drug we used to treat people with opiate dependency because it kicked off opiates of abuse. It stuck on there, but it didn't stimulate the opiate receptor very much. That was the drug out there, buprenorphine, Buprenex, Sublocade, that's what everyone knows it as. And it held the lead for the strongest binding affinity, the highest KD value. I mean, it latched on really hard, kicked everything off, but it didn't cause respiratory depression. So we're like, wow, this is great. You can't get high on this drug. If you shoot it, you could, but it kicked off all opiates of abuse. It latched on so nothing else could come on there, so you really couldn't get high on it. But then these other compounds, the nitazene compounds, isonitazene, metonitazene, protonitazene, and itonitazene. What's different about them is when they latch on, they have a vice grip. It latches on to the opiate receptor stronger than buprenorphine, which was the Mac Daddy for binding affinity. I mean, it latched on stronger than anything else. But now you have something that latches on stronger than everything else we know. Why is that a problem? That means if you take it and you overdose and we give you naloxone, which is the anti-opiate, which kicks the opiate off the receptor and prevents respiratory depression and immediately gets someone out of an overdose from an opiate, doesn't work. So no matter how much you can give 4 or 5 times the amount, doesn't work that well because the nitazene compounds latch onto that receptor so strongly. This is why they're so dangerous. They latch onto the mu-opiate receptor, with a very high KD, meaning their affinity for that receptor, their latching on ability is so strong nothing can kick it off. That means you go into respiratory depression and you die. That's why these drugs are so dangerous. That's why they're called the Frankenstein drugs. And just some basic information on them. Isonitazene is 500 times as strong as morphine. Metonitazene is 100 times as strong as morphine. Protonitazene is 200 times as strong. But the Mac Daddy of them all is Ito. And that's a street name. They say, you want some Ito? Is 4,300 times as potent on the mu opioid receptor. The receptors are the mu, the delta, and the kappa. The mu is the one of addiction, so there's 3 types of opioid receptors. The delta is the one that causes depression and hallucinations and delusion and spinal anesthesia. The kappa may be the one opioid receptor which helps relieve depression. There may be further study on that receptor. But I'm very concerned with abuse of these nitazene compounds because of this high binding affinity for the mu opioid receptor. And all the drugs we use, naltrexone, naloxone, to undo opiate overdose don't really work. So if you're getting an overdose from a nitazene compound, you have to give a lot of it, and it doesn't work that well. It's very concerning for me. And that's why these drugs are so dangerous in overdose. So beware. In the world we live in today, you don't know what you're getting. So just a common user just fooling around, playing around with something, gets a nitazene compound, gets carfentanil, you're really going to get yourself in a big trouble. The nitazenes stick on the receptor and you can't get them off. And the carfentanil is so potent, you overdose from respiratory depression. You can't breathe and you die. That's the key issue with these nitazene compounds. Thank you.